Thanks, Michael. So NANOG would like to once again thank Juniper Networks for sponsoring Hackathon 73. The event took place this past Saturday, and it was an all-day event. All in, we had 39 attendees. There was a sampling of network engineers, system admins, and recent grads across various vendors, providers, and hyperscale companies. There was not only a sense of learning something new technology, but also benefited from meeting and working with new people. I'd like to talk a little about the actual event and then bring up the top two teams. The hackathon was focused on security and automation, something we all need to think about. These were the 5 takeaways. Understanding that automation plays a crucial part in security. The importance of interoperability and integration, scope of automation for security, and that security will require multiple parts of your organization to work together. And then finally, understanding DevSecOps. So what's DevSecOps? I'll leave you with this quote. In other words, when you hear DevOps today, you should probably be thinking DevOps QA test InfoSec. The participants were broken out into 9 teams. Part of the morning was spent laying the groundwork, as well as talking about the importance of a system with a message bus and feedback loop mechanism. Each team had servers front-ended by a VSRX firewall that they were required to secure while allowing only good traffic in. Teams started out with tools like Security Onion and Kibana, but could use whatever other tools they felt necessary. Phase 1 had 1 or 2 attacks that could be manually blocked. Then we amped it up with Phase 2. Juniper amplified the attacks such that the only way to effectively keep services available was to automate the blocking of bad actors. And finally, in Phase 3, along with the automated attacks, we had engineers hacking all the teams. And now I'd like to bring up Team Problem Gopher. Forward. Use the microphone.
Thanks, Vincent. So we're Team Problem Gopher. Brandon, I'm Jason, Gabe, Akshat, and Mike. I think he already had to head back for the day. Wow, Betty was right. It's kind of awkward up here in front of a lot of people. So forward. There we go. Okay, so our talk will be just a quick overview, recap of the topology, what we saw, encountered as a problem, what we'd do differently in the future. So the topology was pretty straightforward. They gave us VSRX routers. Vincent said we had a DMZ and a trust zone. We had to keep some services up and running on those devices. And they ramped up everything. They gave us a pretty good topology, but one of the first things that they started off with was they gave us a salt stack framework. Has anyone used salt stack? Yeah, that was our reaction too. So we looked around the table and said, hey, who's used salt before? What does this Genja templating thing do? Then we started figuring out that we had a lot of traffic coming in from the NIDs on the message bus, so we were able to start parsing that out, get some of those going. So Vincent already had this slide up earlier, but the workflow was basically the message comes in off the message bus, the reactor sees it, and if it matches a certain pattern, it sends it on to React, and then we wanted to extract the IPs and then push information from the IPs off to the firewall to block the traffic. So here's like a sample message bus. ActChat is going to go into detail here in a second, but the orange highlighting there is what we needed to key off on, and then you'll see the blue is the ASCII arrows, and the yellow is the malicious IP tuple that we needed to separate some stuff out of. But I'll turn it over to ActChat to talk about. Yep, click here.
Thanks, Jason. Right, so this is actually part of the code that we were using to try and detect the type of attack that's coming in. So there are different keys that actually get taken care of in multiple files as part of the reactor interface for Salt. And this particular Jinja template actually gets invoked as part of the parsing exercise. Now, the traffic flow that we actually showed you earlier showcases some of the fields that we want to look at, particularly the IP address of the source IP address of the attacker. And once we were able to actually parse that, we can use that to create a VSRX policy over the Salt interface that we have. And this parsing interface is fairly simple. It's really just trying to detect, if you can see a couple of IP addresses there, we're whitelisting those IP addresses so that we don't actually block the source NAT interface itself, and also some of the internal subnets that potentially would just be trustable devices. And much of the other stuff is trying to just get the sort of the syslog messages in a way as part of the Salt reactor interface, and use that to split on the source IP and try and determine if we have a unique way of identifying the attack. In this case, the source IP and the port number. And once you've done that, we sort of push it into, as you can see on the right-hand side, the push policy set, which is the separate push policy that gets invoked as soon as we've identified the particular flow. So the RT-IDP as the key value on which we're trying to match uses that to then use the Juno's install config Salt module to go ahead and push the required policy inwards. I think one of the good things about the entire exercise was that even though it was using the Juno's device, we were able to hide it behind the Salt interface. So people didn't really have to learn the syntax of like the vendor interface itself, but could really just work with the Salt workflow. And with that, in much of the overall workflow, this is what we tried to modify and worked further in with some of the manual configurations later on to try and permit certain required flows as part of the exercise. Yeah, and this is part of the YAML encoding that we had to avoid some of the rendering problems. Incidentally, Salt sort of extends the plugins for Jinja to allow you to do an encoding without having to work with quotes and escaping different characters. Yeah, and Brandon, do you want to talk about maybe the policies that you applied manually? Nope. Okay, so I'll continue. And the idea was that there are two different portions of the network that we had to deal with. There was a trust part and there was the DMZ. The DMZ was the portion where some of the pods were located, the web servers that we had to protect against the attacks and make sure that those services stay up. And the trust network is the area that we have our tool server running, where our scripts would be running and passing the attacks and then enforcing the policies on the VSRX. So the policy propagation was fairly simple, but it was all combined together into the Salt stack interface. And I think overall, for all of us, it was more of the set of learnings as part of the exercise, learning how to deal with Salt stack, to work with things like Squirt, Kibana for actually looking at the logs from the attacks coming in. And then combining the manual sort of entries that we use to basically define the permissible flows on the VSRX, and then have the Salt stack do everything dynamically when the attacks start coming in full force. So once they really stepped up the attacks in like the phase 2, phase 3, etc., we didn't really have to touch our VSRX at all. The Salt stack was continuously responding to each and every attack that's identified at every point in time, and all the subsequent attacks get automatically blocked because the VSRX has the policies after that. So I think that probably bolsters the initial intent of the exercise, which is to showcase how you can automate using something like Salt stack or frankly any config management tool, and use that to push policies dynamically as you detect attacks, right? So automation is sort of a key part of the security exercise. Yeah, so absolutely, we would hack again. And if anything, most of us have been participating in all the hackathons consistently. I would also recommend that even if there are folks who haven't coded earlier, please do come by. There are hackathons happening in every NANOG now, so I would recommend joining up in the team that you're comfortable with and just proceeding with the attack, with the exercise. So yeah, you get to learn a lot and you get to code. So I think that's pretty awesome. But thanks to NANOG and Juniper for setting up the entire exercise. Thank you.
Thanks, Team Problem Gopher. And now I'd like to bring up Team Ocean 6 to have them talk about their experience at the hackathon.
Hi, it's not 6, it's just 4, but we were 6 at the hackathon, so we had a few casualties yesterday. Yeah, it's us 6, some folks from Oracle Cloud Infrastructures, Flavio from PayPal, and myself from Leakix. We're kind of an ad hoc group that got put together, and that's not a bad thing per se, because we won 2nd place, and so I think you just have to be open and find yourself together in a team and start working on the topic. So in contrast to the other group, which gave you a lot of technical details right at first, we would like to explain to you more about what we had to do as a task, or what happened actually, because this was a red team, blue team game. And our task as a participant group was to defend our production network. With all the tools that we have, in the beginning we noticed that the attacker was doing some very simple SYN flooding and ping flooding, probably with a tool like hping. And we detected those just from looking at the syslogs. The syslogs were collected in a Kibana instance. And for the ping floods, we were detecting it via the security onion tool in the Squirt overview web interface. And we also noticed some service vulnerabilities that were also present in the log, because what it's essentially doing, it's taking a full traffic capture on the inbound and then running it through an IDS row in this instance, and then generating events from it. So if you have anonymous FTP enabled and such stuff, that pops up in the logs. So the very first thing that we did, we knew that we had to ensure that certain services were available, and we were whitelisting those in a global policy. That prevented us from doing fat fingers and by accident blocking something, or in the event our automation happened to do something which was not intended, that the services were kept available. Yeah, we had 2 web servers to secure, and obviously we secured the FTP, and we also patched the servers in one or the other way. Okay. Now I will hand over to Syed, who will explain to you how we configured the virtual SRX router.
To prevent our services, either we had to go on the server and patch it, and Benedict will talk more about it in later slides. I was working on the SRX side of it, so what we did, we actually quickly saw some of the SYN floods that we are able to configure manually to block it on other policies, and then make sure that that's gone. And we were looking into the ping floods, but more on that later. We also noticed that if we want to automate it, we probably want to re-simplify the policy so that we have a workflow that we can quickly update using salt mechanism, and just don't have to rejigger a lot of policies with the salt updates. So we moved our global policies or our NAT policies, or even later on we figure out we have to put the NAT in because we blocked our NAT IP as well as a part of attack. So we created a global policy, make sure that we have address books out there that we can add bad IPs to, and then towards our trust zone and also towards our DMZs. So initially, it was pretty easy to manually block it, and as attack ramped up, we realized that we have to get our salt stack up and running and make sure it works. These are the messages, like probably you already saw that in the last presentation too. So some of the key fields we parsed on was RT, IDP. So these are the syslog messages we were getting from SRX to one of our salt master. The key fields we were parsing on was RT, IDP, so that means it's attack, then source and dest, and then the severity of the event. There are a couple of fields in yellow that we probably wanted to parse on as a future enhancement, but these were the key fields we actually parsed on. So this was the script, our parser. So extract IP was one of the script that actually went through the log and parsed through it. Bobby, you want to add to how we did the parsing?
Yeah. So basically, so one thing that was kind of a challenge was that the data, the type of the data was, it would change a lot because we were being attacked, and the syslog messages would change a lot. So basically, every time we would get some different type of event, sometimes it would break the parsing. So we would have to change that on the go, and we had multiple basically iterations trying to get that data from the logs, right? And at some point, like we mentioned, and that's the reason we changed the policy, we even blocked our own access to the system using the automation. So that was part of it. Yeah. So do you want to talk more about this part?
Yeah. So this is showing the web interface of the Squirt tool, and now that we had all the automation up and running, we could fight the attacks coming in from different IP addresses. But we also noticed, when carefully looking at the events, that there were some attacks that had only very few packets. They have a very low footprint, but they managed to get remote code execution on one of our servers. And we followed the trace that we found there. And basically, it was a vulnerability in a Tomcat Java application server that allowed remote code execution on the machine. So we checked the server, and we saw that there were some showcase applications running that were supposed to have this vulnerability. So the solution basically was to keep the service available, but to shut down those particular vulnerable applications. And besides all the automation that you might have in place to fight volumetric attacks, you need to be careful because there's, depending on the software that you're running, many vulnerabilities how an attacker can sneak into your network through the services that you are offering. And if they are insecure, take over the network. So that was our solution to this thing. We'd like to share some experience with you that we had while learning SaltStack. So SaltStack, we're kind of all programmers and software guys, but SaltStack was a bit new of us, and we found it to be a quite steep learning curve at the beginning if you start from very scratch, but it's also a very powerful tool. We found it hard to diagnose because mainly we were just not using it in a very sophisticated manner. We were kind of naive, just doing things, and then we waited for the next attack to come in. We could have been more clever, and so we could have prepared some tests actually with fake or dummy data in order to test the stuff that we're automating. As we said, we had some errors with the parsing, and this broke our automated policy push, but we were able to fix it later. However, pushing the policy to the actual device was pretty easy. We didn't have to know any Juniper commands at all. We could have done the same with Cisco or other vendors. And SaltStack provides a very good level of abstraction from the actual hardware being used. Yeah. So what you also might want to think, you need, when you're doing something like this, you need to get a complete picture of what is going on. So we noticed that we did receive logs from the SRX, but no messages from our intrusion detection and prevention system in our message bus. So if we could have also received those messages, we may have been fighting those small volumes targeted attacks in an automated way. So lessons learned, basically, if you have data sources, make them all available in one big system so that you can attach to the data sources and act accordingly. Yeah. About the SaltStack event log structure, yeah. So when you have raw syslog messages, they're kind of unstructured, and they're getting converted in a SaltStack structure, and you have to, just to be careful what data you're using and if you're doing it correctly. Okay, I think, the last slide is basically what we may want to do better in the future. We would like to switch over to test-driven development. We would also like to, we treated basically everything that we are seeing in the logs as very important, and we need to act upon it. But the IDS and also the other systems, they had a level of threat attached to the log messages. So we could have been filtering on those and only acting upon the high threat level messages. And for example, the medium and low threat messages, we could have just forwarded them to an engineer for manual review if there needs to be some action taken or so. Flavio wants to say something.
Yeah, so let me just emphasize this, in terms of developing the code, because the software is event driven, right? So whenever we get an event, then we parse it and take an action on it. That has slowed down development significantly for us because we would wait on the attacks. So that's one thing that the test-driven development would have made it much better. You know, if we written the tests before and prepare some inputs, and so we could test it more fastly. So that's definitely one of for me, the biggest lesson. Yeah, that's all I wanted to emphasize. Anybody want to mention anything else?
Just last few things, like for most of us in this team, it was our first hackathon, so I strongly recommend and encourage other people who haven't done a hackathon to attend it. Most of us didn't have any background of doing any other hackathon, so it's not really, just go through the experience, and I appreciate Juniper and NANOG for arranging it. There'll be next one in Vancouver, so strongly encourage everyone to attend one. There'll definitely a bunch of learning for all the skill levels. So thank you. Thanks, Juniper. Thanks, NANOG.
And that's the Hackathon Recap. Again, thanks to NANOG and Juniper Networks. And let's give one last round of applause to all of our participants as well as our winners.